Okay, section 3.3 is all about compound inequalities, which this is where they put two inequalities together. So whenever you do this, there are two types of compound inequalities. And the first one is an and inequality, and the technical term is a conjunction. Okay, so whenever you solve these, you're going to, on your number line, you're going to have something that looks like this, where it's a range between two different points. Okay, and then the second type is the OR problems, and the technical term is a disjunction, which that's not as important as knowing it's an OR, and an OR problem will look something like this, where there's two points and then they're going off in opposite directions. So the AND problems come together. So whenever you solve a problem that has an AND in it, they come together and they look like this. And the OR problems always go off in the same direction, or in different directions, excuse me. Okay, so let's actually do some. So solve each compound inequality and graph its solution. So we've got two different ones. So I know there needs to be a 0 and a 5 on my graph. I think the easiest way for me to do these is to write them separately, and you probably are going to agree after you see it, because this is kind of hard to see. So let's start with the easy one. We have x is less than 5, right? That's the whole right half of the equation. That's the inequality. That's the easy part to see. The other part is the left part, and it's kind of a pain in the butt because you have to read it backwards. So I like to rewrite it in a format that is easy to read, and so it's going to be x, and you have to flip the inequality so where it's pointing, it needs to make sure it's still pointing at the 0. So x is greater than or equal to 0. Okay, so now that we have our two inequalities, we're just going to graph that. So we're just going to make a number line. It looks like it needs to go from 0. We'll count by twos. 1, 2, or 0, 2, 4, 6, 8. It doesn't really matter. I'm just making it up. I think on your homework and stuff, it's actually, the number line is provided for you, so you don't have to worry about it. Okay, so let's graph the first one. X is less than 5. So 5 would be right here in between 4 and 6, right? And that's going to have an open dot, and it's going to be going this direction. And I'm not going to shade too far because I don't want to go past my other point. Okay, so we just know it's going in the left direction because it's less than 5. Okay, the other one is x is greater than or equal to, so that's a closed dot. So greater than or equal to is going above. And so that's what this looks like. This is an AND problem or a conjunction. Okay, and usually when they write these as compound inequalities, like they did up here, it's going to be an AND. If it is going in opposite directions, I don't want to say always, but almost always, they'll have to say the word OR. Okay, let's do another one. So I'm just going to rewrite them. We have y is, I'll do the easy one first, greater than or equal to -3. And then y is, and it needs to be pointing at the y for the second part, less than or equal to -9. And it's super easy to mess those up, so be very careful. Okay, and also be careful because we're talking about negatives, and so you kind of have to think backwards on the number line because you're on the negative side. So I'm just going to start at 0. I'll just count by 3s. Again, it doesn't matter because they're going to be provided for you in your homework. Okay, so let's start. So y is greater than or equal to -3. So it goes this way, right? And then y, I need to have a closed dot, my bad. So closed dot because it's greater than or equal to, and then less than or equal to -9. So I was wrong in telling you that it's going to be an AND problem. This is an OR problem, a disjunction, because they're going in opposite directions. Okay, Now we're starting to do the inequalities, but with equations, not just a letter. We're gonna have to do something with it. So there's a couple different ways to do this. You can break it apart. I think it's less fun to break it apart. I enjoy solving them a little bit differently. And depending upon if you had Miss Hacker, she solved them this way. I think Mr. Lauritsen breaks them apart. I'll show you both ways just so you can see which way you like better. Okay, so a minus 2 is the center. And so now we have 3 sections of this inequality. And so you're used to doing it to 2 sections. So whenever you have this, just like whenever you have equations, you have to do what you do to one side, you have to do to the other. Same thing, but now we have 3 sides. So if you do something to one side, you have to do it to all 3. Okay, so let's get this a by itself. And so right now it's being subtracted by 2. So we have to do the opposite of that and add 2. And we're going to have to add 2 to all 3 sides. Okay, those cancel. And we have a in the middle. Do I need to flip my sign? The answer is no, because we didn't multiply or divide by a negative, so we don't have to worry about that. So then you have on your, and I'm just dropping those signs straight down, don't flip them. So 0 plus 2 gives you 2, and 6 plus 2 gives you 8. All right, now we can write them separately to graph. So we have a is less than 8, and then a, the arrow needs to be pointing at the 2, so is greater than 2. All right, before I graph these, I just want you to watch. Here's the other way to do the exact same problem. So let's break it up. So we have 0 is less than a minus 2. That's one side. And then we have a minus 2 is less than 6. So all I did right there is I just said, okay, here's 1/2. I'm going to put it right there. Here's the second piece. I'm going to put it right there. And now I'm going to solve them. So I would here add 2, add 2, so 2 is less than a. And then on this one, add 2, so a is less than 8. And if you flip this around, the arrow is still pointing at the 2. So we get the same exact answers. It just depends. I think this first way is a little bit more fun because it's something different. It's not just like the normal old equations. But anyway, I digress. So let's count by 2s. So 2, 4, 6, 8, 10. Sure, for fun. Okay, so we need an open dot at 2 and an open dot at 8. Let's graph the 8 first. A is less than 8, so it's going this way, and greater than 2, so it's going this way, so this would be an and problem. They would connect. All right, next one, I'm going to do it my way, or my favorite way, I should say. All right, so right now we have x divided by -2 in the middle, and we need to get that -2 off of the x. So what's the opposite of dividing by -2? And that is multiplying by -2. So we're going to multiply every single one. We kind of don't have a whole lot of room, but that's okay. Eat all of 3 pieces by -2. Those cancel. Since we're multiplying by a negative, we must flip your sign, or our signs, because anytime you multiply or divide by a negative, you have to flip it. So I'll just go ahead and flip it now. Okay, and those -2's canceled in the middle, so you're left with x. And then we can just do the multiplication. -2 times -18, that would end up being +36. And 12 times -2 is -24. Okay, so now let's go ahead and put it together. So we have x is less than -24, and x is greater than or equal to, because it needs to be pointing at the 36. 36. Okay, so, oh my gosh, I'm going to count by 12s. You can just copy my number line because, like I said, they will be done for you. So we'll put 0 in the middle, and then -12, -24 off to the left, And let's do 12, 24, 36. All right, so we've got, it looks like an open dot at negative 24 and a closed dot at positive 36. All right, so x is less than negative 24, so it goes off this way. And greater than or equal to 36. Double check that you have an open and a closed dot. And that's it. All right, now let's do a two-step equation. So I'm going to draw our lines. You solve it just like you would another two-step equation if there's just two pieces, except for you do it to all three sides. Okay, so we're trying to get rid of get the n by itself in the middle. So we need to isolate this term first. So we need to get that 4 off of there. Since it's positive, let's go ahead and subtract it. So minus 4, do that to all three sides. Those cancel, and you have 9n in the middle. Drop your signs down. And let's go ahead and subtract. Be careful. Negative 14 minus 4 would give you negative 18. And then 67 minus 4 would give you 63. Okay, so now we need to get the n by itself by dividing by 9. Do you flip? The answer is no, because that 9 is not negative. Okay, so n in the middle, and we're just going to drop our signs straight down because they didn't flip. Negative 18 divided by 9 is negative 2, and 63 divided by 9 is 7. All right, so I'm going to write them separately so we can graph them. N is less than or equal to 7, and n is greater than negative 2. Let's count by 2's again. So negative 2, 0, 2, 4, 6, and 8. All right, so we need a point at 7. So 7 is in between 6 and 8. It's going to be a closed dot. And then we need a point at negative 2, and that's going to be an open dot. All right, so n is less than 7, so it's going this way. And n is greater than negative 2, so it's going to look like that. So beautiful. Try F. Pause the video and try F by yourself. Okay, so let's add 3 to isolate that variable term. And those cancel. So we have 10k in the middle and then drop your symbols down. On the left side, it looks like we have negative 40, and on the right side, it looks like 10. All right, get the k by itself. We need to divide by 10. Do we flip the sign? And the answer is no. So negative 40 divided by 10 is negative 4, and 10 divided by 10 is 1. So we have k is less than 1, and k is greater than or equal to negative 4. So negative 4, negative 3, negative 2, negative 1, and 0. Cool. So open dot, oh, I guess I need to go to 1. Sorry, I thought it was a 0. Okay, so open dot at 1, closed dot at negative 4, and it's less than 1 and greater than or equal to negative 4, so they connect. It's an and. All right, and then sometimes they're going to give it to you like this, where it's not written as a compound inequality. It's just two separate inequalities. And when you see this, you should be, whenever you end up graphing them, you should know they should be connected in the middle. Okay, so if they're telling you it's an and at the beginning, it will stay an and the whole time. Okay, so let's do the first one. So we've got x plus 2 is greater than negative 2, x plus 7 is greater than negative 2, and x divided by 2 is less than or equal to 0. Cool. So let's solve the left one. So we're going to subtract 7 from both sides. Those cancel, and you have x is greater than, that would be what, negative 9? And then the other one, it's x divided by 2, so we have to do the opposite and multiply by 2. So x is less than or equal to 0. 0 times 2. All right, so now I have all my inequalities. I don't even have to rewrite them. They're ready to go. So it looks like I need to go from -9, let's count by threes, -9, -6, -3, 0, 3. Okay, so we got an open dot at -9 and a closed dot at 0. And then it's greater than -9, so it's going this way, and less than 0. Hey, that's what we predicted up above, right? We said, hey, it's an and, they should come together. There's your answer. All right, same, let's do this one. So it's the same thing. So we have two separate ones, but this time it's an or. So that tells you they should be going in opposite directions, but let's see if that happens. Okay, so we have b minus 9 is greater than -2, so let's add 9. Add 9. So b is greater than, dropping the symbol down, 7. -2 plus 9 is 7. All right, this one, divide by -6, divide by -6. b is, oh wait, maybe I was wrong. I think I am. No, I'm not. Okay, we need to flip our sign. So flip your sign, because we divided by a -6, and it becomes -2. All right, so let's go ahead and graph it. Oops. Let's just count by 2. So -2, 0, 2, 4, 6, and 8. All right, so we have a point at -2, and that's an open dot, and an open dot at 7, which is directly between 6 and 8. All right. B is greater than 7, so it's going to this direction. And then less than -2, so it's going this direction. So do you see how if you had not have flipped your sign right here, it would have given you the wrong answer? Because it would have. All right, we've got 2 more to go. I'm sorry this video is extra long, but it's good for you. So 6v minus 3 is less than 15. And -3 minus 5v is less than -38. Oh, wow. Okay, so let's go ahead. It's a two-stepper. So we're going to isolate this term by adding 3 to both sides. So I have 6v is less than 18. Divide by 6. V is less than 3. All right, the other side, lots of negatives over here, so be careful. So we need to isolate your variable term, which is the -5v. So I'm gonna get rid of that -3 by adding 3. So plus 3, plus 3. We have -5v is less than -38 plus 3. That would be -35. Divide by -5 and flip your sign because you divided by a negative. So this would be v is now greater than -35 divided by -5 is 7. All right, let's graph it. So we have, I'll just count by ones, 3, 4, 5, 6, and 7. All right, looks like open dot on 3 and open dot on 7. It's going to the left because it's less than 3, and then going to the right because it's greater than 7, and hey, sure enough, it was an or problem, so that makes sense. Last one, pause it, try it by yourself. All right, got 2x minus 8 is less than -16, and 10x plus 7 is greater than or equal to -53. So let's go ahead and add 8 on both sides to the left one. So 2x is less than, that would be +8, or no, sorry, excuse me, -8. Divide by 2, divide by 2. X is less than -4. And then the next one, we are going to subtract 7. 10x is greater than, that would be what, negative 60, I believe. Divide by 10. X is greater than or equal to negative 6. All right, these are close, so I'm going to do negative 6, negative 5, negative 4. Open dot on negative 4, closed dot on negative 6. So x is less than negative 4 and greater than negative 6. So that's what it looks like. And that makes sense because it was an and problem. All right, that was it for Unit 3. Thanks for watching.